Welcome everyone to the ESPRIT and Harvey Performance Company webinar. My name is Dan Perry and I'm the Eastern Applications Manager for DP Technology. So today's session will be broken up into two parts. Our first presenter will be George Nacarado. He's an applications engineer for DP Technology, and he'll be followed by Darren Kern, who's a senior applications engineer for Harvey Performance Company. So throughout the presentations, we would encourage you to use the GoToWebinar utility, which should be the panel on the right-hand side of your screen. There's a questions dialog there that you can use to type in your questions throughout the session. And Darren will be fielding all of the Harvey questions, and I'll be handling the ESPRIT questions. And then at the end of the session, we'll have a live Q&A where we'll try to cover some of the more frequently asked questions that transpired throughout the session. So with that, I will go ahead and change the presenter to George, and we'll get started.
Hi, my name is George Nacarado with ESPRITCAM software. Thank you for tuning into the ESPRIT and Harvey Performance webinar. We are going to cover tool assemblies using Harvey and Helical downloadable tool libraries, profit milling with rotary phase pocketing, profit milling with Z-level roughing. Harvey has created tool libraries that you can download from their website. This library includes all the available end mills for Harvey and Helical. This can save you a lot of time by having all your tools available and already defined in ESPRIT. Why do you want accurate representation for your tooling? The newest version of ESPRIT uses the virtual machine definition to construct artificial intelligence, which is used to make decisions for the programmers, linking movements like positioning between cuts and operations. They are produced automatically by the software based on the machine kinematics and travel limits defined in the machine setup. Tools loaded into ESPRIT 2000 series will come defined as shown. The tool length represents the recommended stick out by Harvey or Helical. The overall length represents the full length of the tool. The overall length beyond the stick out will show as a holder extension. This makes using tools easy as no modifications are required to get realistic looking tools into your ESPRIT with their library. When adding a tool to the latest version of ESPRIT, you will need to add a tool holder as well. This is to help make virtual clone of your machine that allows the software to make decisions for your movements to avoid collisions. When adding a tool holder, there are two options. You can create a tool attachment position, also known as a TA, at the tip of the holder, making the tool base start there. This allows you to quickly and easily shift the tool the amount you want in the holder via tool shift. The second option is to create a TA position in the holder that you want the base of the tool at. This method, you will not have to adjust the tool shift to have the tool at the specified depth in the holder. All right, let's move into the live demo. So first, I'm going to go into the website for Harvey Performance, and you can quickly and easily download Harvey tool or Helical tools. So just download some Helical tools. And now I'm in my ESPRIT KBM manager. I'm going to create a new tool group. I'm going to call this tool group Helical Solutions High Feed End Mills. Once I've done that, I get a blank tool group. This blank tool group, I can just right click inside the white box, go to File, Open, and I'm going to select Helical Solution High Feed End Mills. An entire list of all their high feed end mills load into the knowledge base. All these tools can be quickly and easily brought into ESPRIT. A very expansive list, and they have many other tool groups that you can load in as well. So now I'm going to show you how this works in the ESPRIT 2000 series. Once I'm in ESPRIT, I already have an operation that's going to use a tool not from Harvey's library, right? But I want to change this out because I want to use Harvey's tools and get some speeds and feeds. So I'm going to hit stop in simulation. I'm going to go to the tools. I'm going to open my cutting tools manager. Once this is open, I can quickly and easily search. So I want a bull nose end mill, tool diameter 1/2 inch, tool length 2.5, flute length 0.625. I'm looking for a 5 flute. And if you see right here, the comments, Helical and Harvey, they've spent so much time and they've built this tool library to be very expansive. And it tells you every detail for this tool. So I can quickly find 35242 end mill for steel, 5 flute, tells me everything I need to know about the tool. I'm going to click add selected tool to ESPRIT. That tool gets instantly added into ESPRIT. Now I want to come in here and adjust my stick out a little bit. So I'm just going to come into the extension. And right here, the tool is 4 inches long, but only 2.5 is sticking out from the holder. I'm going to adjust that to 1.5 and hit OK. Now I can come over here into my operation and switch which tool I'm using. So I'm going to switch it over here to this 35242 tool we loaded in. Now I want to get speeds and feeds for this. So I'm just going to come over here, go to the Machining Advisor Pro, type in the tool I'm using, automatically loads in. Material, steel, alloy, 4140, normalized. Tool path, high efficiency milling. Spindle, I'm using a Cat 40 with a milling chuck holder. My stick out, I'm going to adjust to the stick out I set on my tool. Radial depth, I'm going to set this to 10%. Axial depth, I'm going to set this to 0.6. And I get updated. Well, let me adjust that back to 10 and lock it, and then lock this one. Right, so this is going to give me all the speeds and feeds I need for my operation. So I'm going to take these speeds and feeds and put them into my operation. So come back into ESPRIT. And we had 545 for surface speed and 102 for feet per minute. 545, 102. Next thing I want to do is go through the operation and make sure the operation is set for my tool. Max vertical plunge, my tool flute length is 0.625, so I'm going to set this to 0.6. Set my step over of diameter to 10%, as we told the Machining Advisor Pro. And then I can hit OK. And I've quickly built an operation with speeds and feeds using a helical tool. Once this operation builds, I can show it in simulation. And you can quickly see how well the tool came in. The stick out's already there. All the diameter for the tools are there. It automatically has all that information built in. The Cat 40 holder is built into the machine, so whenever in the 2000 series, it automatically is going to put the tool holder inside this style look. So once you have the operation good, we're good to go on this. So let's move back into the rest of the presentation. Initially, profit milling was not supported for rotary cycles, but it has been added to cover most machining situations. There are still some limitations as it isn't available in wrap pocketing, but we will be showing you today how to accomplish profit milling on the OD of a part using your C-axis. Profit milling on a rotary face pocketing operation will use X, Z, and C. The position of the C-axis is adjustable to give you customization on how much of your Z-axis or Y-axis you are using. By default, this operation will use no Y. We will create the pocketing operation on a chain that we create representing our stock material and set the feature on the part as an island. We will enable polar interpolation to get the best NC code output. When rotary machining is enabled, enter the angular position of the tool measured from the x-axis. This angle controls the y position of the tool during rotary machining. When set to 0, rotary motion occurs only on the x and c. When set to 90, rotary motion only occurs on y and c. And you can do any angular position between 90 and 0 to move around how much of your x and y you're using. When rotary machining is used, indicate whether to use polar interpolation. This setting depends on the capabilities of your NC machine and the machining situation. As you see on the left side, polar interpolation, no. Toolpath is created in small segments. The feed rate is calculated on every line and degree per minute. On the right side, we have yes. Moves are interpolated according to your NC machine capabilities. You will see the regular program feed rate because the machine can and is converting the feed on the control for the interpolation. This shows the feature we will use in more detail. The open edge chain is the diameter of our stock before the operation. This is informing ESPRIT the area to cut and letting the tool go outside this area. The island feature is a profile that we will define as an island in the pocketing operation. All right, so let's move into that demo as well. So I've got my part here and I already have the operation built. And so we can see what that looks like. All right, so we have a complete part. So I'm gonna hit stop in simulation and we're gonna build this from scratch. So I'm gonna delete my profile and my operation, delete this circle. I wanna define a circle that represents the stock that's remaining. So I'm gonna go to geometry, circle 1, and create a circle. I'm gonna set my diameter or my radius to 2.75. So whenever you have a circle, you start typing, a box will show up. I hit enter, it draws the circle. All right, now I need to create features using this circle and the model. So I'm gonna create a feature. I'm gonna select this circle right here and just auto chain it. The auto chain just creates a chain. Now I'm gonna change that definition. So I'm gonna go to one chain. All right, I'm gonna go to machining in my properties window and set my depth. There's two ways you can set your depth. You can just type in a value, or I can use the digitize arrow right here and just select a piece on my part. Once I've done that, I need to open the chain up so the tool is allowed to come in and out of this profile. So I'm gonna go to sub elements, and I'm gonna go to attributes and set open edge to true. All right, so now my chain is dashed, meaning the tool can come in and out of it. Now I need to create a profile that represents the island, the part I wanna finish. So I'm gonna hold shift. Shift is gonna propagate around a face. So I'm gonna select this face and get all the faces. Once I do that, I come up here to the top and click wall. So now I've created a profile that I'm gonna finish, and the chain around it represents how much material I wanna remove. So selecting one chain, I'm gonna come over to milling and select pocketing. Usually you would see rotary face pocketing, but in the latest version of ESPRIT, pocketing will do it all. All we have to do is enable rotary movements and it'll treat it like it's a rotary face using your C-axis. So the tool's already loaded in. I'm using one of Helical's tools, 27257. I wanna make sure that I have rotary machining and polar interpolation set to yes. Again, polar interpolation is an option and depends on the situation, the machine you're using. But if we want to use C-axis, we will have to set rotary machining to yes. On the strategy, I'm choosing profit milling. I'm going a little bit past the actual depth because my tool has a radius and I want to actually create a flat around this island. All right, so now I'm going to show you how I'm loading in my speeds and feeds. So what I did was I actually used Machining Advisor Pro, and I have all their PDF printouts of the speeds and feeds, which is super awesome. You can add it to your, the documents that are going to go to the machine so the operator can see everything he needs to see. Right, so my radial step over is 8%. My surface speed is 761, excuse me, and feed per minute is 269. So I'm going to load that in. So I'm going to go to rough, choose 7 761 for my speed. Per minute, 269. Same thing for Z. Set this at a very large value. This is for micro lifts in case we need them. It's my step over. I'm going to set to 8% as it's already set. And I want to set my island feature as well. So I'm going to delete what current island feature is in there. And I'm going to select my profile. Once that profile is selected, it knows that it doesn't want to go past that profile. Set this to 110% so the tool can come all the way off this circle and clear any material. Also in here for added during the profit milling and pocketing, anytime it sees a slotting strategy, it's going to change its cut speed, feed rate, and incremental depth. So I actually have that printed out for this specific tool as well. So the slotting strategy is 293 for surface speed, and feed per minute is 41, and incremental depth is 200 thou, as shown right here. So if I hit OK, I build my operation. Once the operation's built, I can simulate and get complete. All right, let's move into the rest of the presentation. Profit milling for Z-level roughing. For profit milling on the OD of your part, you will need to use Z-level roughing with follow curve floor. This operation is a 5-axis operation with the option of RTCP available. If the drive entity type is set to cylinder, you're building an invisible virtual cylinder for the tool to follow. The cylinder is made up of 3 parts: the cylinder seam point that creates the location where the virtual cylinder seam is, the axis start point, and the axis end point. They define the ends and the location of the axis center line. If your drive entity type is set to revolution surface, you're building a surface from a profile by defining the profile and the 2 points for the surface center line. You can choose whether the revolved surface is machined on the outside or inside by choosing an option for internal / or external machining. If drive entity type is set to surface, click the selection arrow next to the floor surface and then select an existing surface in the graphics window. You can also select any face on your part as a surface to follow using drive surface. Drive entity type set as surface. When you're using surface, note the machinable area is in the normal direction of the drive surface. The surface normal, white arrow, should point towards the tool. To reverse the surface normal, set reverse surface normal to yes. We are going to use between curve finishing operation to finish the floor for this pocket. We can use the Machining Advisor Pro to determine the speeds and feeds, as shown earlier, as well as the step over to target a specific surface roughness we want. This operation has the available option of avoid collision by tilting. This will allow us to machine as much as possible while also preventing collisions. All right, let's move into that demo as well. So I'm going to open up that file. Sorry, this is a larger file. It takes a second to load. So I have everything already complete in here, and we'll rebuild it as well. First, let me show you what we've got. Current roughing operation. And I can show you the between curves before as well. All right, so when you first open it, it needs to build the operations. Now the operation is built. Sorry for the delay. All right, still building those operations. What I can actually show you is something cool. I can show you analysis. toolpath analysis is a really handy tool, and you can see every little detail instead of trying to watch it in simulation. So on the toolpath analysis, I can click play and watch as the tool tilts to go around these corners and around the walls. All right, I can also press pause and I can move and find out where I may have an issue or find out exactly what the tool is doing in certain locations. You can also trace tool axis and see how it tilts, and you can show the tool axis. So if I hit step, I can kind of see where this axis is in those very specific locations. All right, so now it's loaded. Let me show you simulation. All right, let's build this from scratch. All right, so I'm gonna show you how to build this from scratch. We're gonna build a feature first. We're gonna build 2 freeforms and then some chains to define our toolpath. So I'm gonna go to freeform. For my roughing operation, I'm gonna select this entire pocket. I'm gonna hold shift, select that face. I'm gonna hold shift and select this edge to get all the radiuses around. Now I'm gonna do the same thing on this wall and this radius. Now I'm gonna select the floor. I have that freeform created. Now I'm gonna create the freeform for my floor finish. Click freeform. For my part, I'm gonna select the floor. For my check surface, I'm gonna select the entire part. All right, now I need to create a chain to loop around the very top of my roughing operation to prevent the tool from trying to machine all these pockets. So I'm gonna select my loop, click auto chain. I'm gonna also chain this boundary because this is a flat, and so it won't be able to be created precisely and correctly using a follow curve floor. So we'll have to do a separate pocketing operation for that. So with that loop selected, I'm auto chain that. I'm also gonna auto chain this loop down here, which is all the way around for my between curves finishing. And I'm gonna auto chain this loop as well for between curve finishing, so it knows the 2 boundaries I wanna machine between. All right, 3 things I wanna adjust with some of these chains. This chain right here, I don't want a depth on it because I'm also gonna use it to finish this top. So I'm gonna come into the properties window and remove the depth. Right, I wanna set all these edges to open so that the tool can come in and out and it doesn't force it to try and helical down into the middle of the part. So I'm gonna hold shift and select the chain, but I'm not gonna select it all the way. I'm gonna right click and get a piece of the chain. Holding shift is gonna let me select each piece of the chain so that I can quickly set them all to open edge, as we did on the second demo. All right, so now when I select that chain, you'll see dashed lines. Now for chain 3 and 4, using between curves, 2 things have to be true for the chains. Their start point has to be at the same location and their direction has to be the same. So let's check the direction. They're both going the same direction, clockwise from our current view. So now I just want to make sure the 2 start points are at the right location. So this one's start point is right here, so I need this chain's start point to be right here as well. So I'm gonna select chain 4 and see where the start point is. Start point's over here. So I'm gonna click in the properties window on chain 4. I'm gonna click the digitize arrow and select this as my start point. Now if I go back to chain 4, my start point's correct. So now I'm ready to begin programming my roughing and between curves program. I'm gonna select one freeform. I'm gonna come over to the freeform tab and select Z-level roughing. Once this operation opens, I'm gonna go to toolpath, or general actually. Make sure the right tool's selected. I also wanna make sure I'm loading in my follow curve floor speeds and feeds. Open up back T&G up. right? So my 964 is my surface feet per minute. Feet per minute 163, step over 8%. Another option in here, this is optional, but RTCP is available. 8% step over, so that's good. A very important one on this one is it looks like we're using a smaller tool, but that's because we want to build a machine between these two sides, right? So this side right here is going to show up as a slotting strategy, and that's where you're going to get to see how ESPRIT handles the difference when it sees that it's slotting and not actually just straight roughing. So I'm going to open up my full slotting strategy page and make sure that these values are right. 293, feet per minute 31, axial depth. So it's going to take different depths, whether it's slotting or just doing profit milling. Right? I want to set my limits, right? There's two boundaries. I don't want to go outside this boundary, so I'm going to select that. And I don't want to cut inside this boundary, so I'm going to select that boundary. Now, the most important part to get this to be a C-axis driven operation is I need to go to 5-axis and set follow curve floor to yes. I'm going to set my drive entity type to cylinder, and then I'm setting 2 points that represent an imaginary line in the middle of my axis, or in the middle of my part. That's one of them, and the other one is on the other side, and the other side of this plate. So I'm going to hit OK, and I will get an operation. Now, the cool thing is it's going to be building this operation. Oh, looks like there's a step over wrong. Let me open that up. As you can see, it told me exactly what the error was. So let's come in here and find step over. For some reason it didn't calculate. So if I hit 8, I'm going to change it and then change it back to 8 so we can get the right value. Hit OK, and now that'll build. Right, once it's building, I can also apply other operations. And I can see it's still building, so I'm going to go to features and choose my chain right here, and I'm going to open the process I created for this flat standard profit milling. Right, so I'm still building operations while previous operations are building. And this is available because I have automatic set here, so it's automatically just going to keep building as I build operations. All right, let's do our floor finish as well between curves. So I'm going to select my freeform right here, and I'm going to go to freeform and select right here, down arrow, get the between curves finishing. With that selected, an operation comes up. I'm going to go to general, make sure I've got my tool, open up my speeds and feeds. All right, surface feed 818, feed per tooth 6/10. That's good. Now the cool thing is I can actually calculate my surface roughness. That's what Machining Advisor Pro is going to give me. I could type in a step over I'm using and it'll tell me what my surface roughness is, or I can target my surface roughness and it's going to give me the step over I need. So I chose 125 surface roughness and I got the step over. So I'm going to come over to toolpath and I need to set my two profiles. So I'm going to set this profile right here. And I'm going to set for my end profile this profile. So it's going to work its way from the outside to the middle. My step over, I'm going to set as 7 thou and 9/10. I'm going to come to collision detection and say avoid collisions by tilting. Right, this is going to allow me to build the operation and it's going to automatically tilt when it gets down to the floor to avoid any collisions with the tool against the wall. Select the freeform or solid face. We can build that operation. And then we can simulate all these operations. One thing I noticed is my A is the wrong direction. So I'm going to hit stop in simulation. I'll come over here to my program and I'm going to edit my rotary solution to -90. I'm going to edit my rotary solution for flat pocket as well. and I see I have a collision on my between curves. So let me try and once this builds, now I can come into simulation and start simulating. Let's look at the profit milling. I think there's an issue. I need to go in and rebuild all these links because I kind of changed the A-axis in between. So let's let them all rebuild. While this is rebuilding, I can also look at the analysis again of one of the operations. Once they're done building. So I can look at the operation right here for my profit milling and see how that looks. Turn off show trace axis. I'm also gonna, so I can see the tool. When it comes over here to the slotting, you can see that it takes incremental steps down to get through the slotting. All right, so that concludes this presentation. I'm gonna hand it over to Darren, sorry, and let him continue on with the Harvey side.
Hey, good afternoon, everybody. Darren Kern here with Harvey Performance Company. Thanks for your time this afternoon. If you're new to the Machining Advisor Pro, you're in for a treat today. If you're a professional at it, you may be teaching me some things. So here we go. As you can see, Harvey Performance Company, we consist of 3 different companies: Harvey Tool, Helical Solutions, and Micro 100. This program we're going to discuss today is primarily Helical Solutions. So the thing here is hopefully you'll learn some things to where you can run faster, push harder, and machine smarter. Here we go, sorry. So the topics we're going to talk about today is why should you choose Helical Solutions Machine Advisor Pro? We're going to teach you how to search by helical EDI numbers or tool nomenclature. We'll go over helical support, and we'll talk about a little bit about the tool path strategies. And first and foremost is how you get started with it, what bells and whistles we have to offer. And then we'll go into the test drive of the program, and then we'll have some questions and answers. So first of all, why should you choose a program like ours, the Machine Advisor Pro? Well, one, it has over 300 different material grades to select from. So it's, you know, myself thinking back as an engineer, one of the biggest obstacles was the different types of material. What speeds and feeds should I run this material at? You know, aluminum is much different than titanium. Titanium is a beast, to where aluminum, you can just feel right through it most times. The interface that you'll see on the Machining Advisor Pro is pretty intuitive, and you can customize different setup options for your shop, what machine you're on. You may have a light duty machine, you may have a heavy duty machine. It has quick search functionality, so when you're looking for a tool, if you have minimum information, you can start typing and it would be populated. Feeds and speeds and depth of cuts are all adjustable. Each machine has a different limit And that's one thing I'd really like to point out is know your limits. If you got a Cat 40 machine, it's not gonna take as much material, you know, as a Cat 50 machine. It's not designed to take a deep and wide cut like a Cat 50 machine or an HSK 100 or HSK 125. It's on and offline capabilities, so it means you can you don't have to have an internet connection to run it. It's available in different platforms, and we have about 4,900 different end mill offerings. I know the slide says 48, but it's 4,900 in our catalog. And it's free to use, so why not take advantage of it? So when you think about the 5-digit number, we refer to that too as our EDP number. You can, when you get into a Machining Advisor Pro, you'll notice the dotted line around the square that this is highlighting the different EDP numbers. And it's really, you see 2 different ones for each line, and it's just dependent on what coding you select. When we talk about nomenclature, you know, you look at all these numbers and letters and stuff and say, hey man, what does that mean? Well, if you have our Helical catalog, I've got it labeled the 2020 catalog. You'll see it on page 160. 2019, it'll be on page 138, and it'll give you really the general description of what all these letters and numbers mean. If you're getting into an issue and you have problems, here's the number and email information that you can get a hold of our tech department, and they'll be more than happy to help with any issues. When you think of high efficiency milling today, and you hear with ESPRIT, it's profit milling. We call it high efficiency milling. Really the difference between the two, when I first started back in 1987 into the machining trade, it was all traditional. So what that means is you can see at the top, the width of cut was at least 50% of engagement of the tool. It was really, you would go really wide with light depths of cut, or heavy depth of cut, and really it was all about horsepower back in the day. Today, the wonderful programs like ESPRIT really have done a terrific job, you know, helping the tool companies to get better and better with feeds and speeds. With that being said, if you look at the different graphics, you'll see AE all over when you're going around the corner, when you're going straight and stuff like that. Really, they have built in their software a way to keep the tool constantly engaged at the same amount of engagement angle, equal to or less than. So with the intelligence they have in their software, you can really take advantage of the different types of tools that we have to offer. The biggest variable that you're ever going to face in the shop is material is always a variable, and it's the biggest one you're going to face in different conditions and types. When you base a decision on what you're going to do, you should always consider the best metal removal rate that the tool has to offer, or your operation has to offer as well. So if you have a fixture that's light duty, it may warrant to always go to high efficiency. If you have one it's pretty stout, you could get into the traditional, take really heavy width of cuts, depth of cuts, and take advantage of it all. But at the end of the day, I would definitely take a look at the metal removal rate when you're planning for your operations. And if you don't know, really the metal removal rate for milling can be calculated by the width of your cut, AE, times the depth of your cut, which is AP, and then multiply that by your inches per minute. And all these calculations are going to happen right in the MAP program. So how do you get it? If you go to helicaltool.com, you can register for the app, or if you already have it, you can log in right from the website. It's available on an Apple iPhone, a Microsoft Surface, or you can run it on an Android phone as well. So when you take a look at the website here, you can see we're going to hyperlink, and we'll start test driving the MAP program. So when you get to our website, you'll see right here, it's highlighted the Machining Advisor Pro. If you hit Get Started, it will bring you into the program. So if you already have a login information, you can log in. If you don't, you can hit get started. You'll fill out this form here. You'll agree to the following terms, and then you'll submit it, and it will come back. You'll get a confirmation email. Now, we have had people, that have gotten the email comes back, and it will go in their spam folder or something like that. So if you don't see it, check your spam folder. If it's not in there, contact us, and we'll get you rolling. Dave Pichette, he's probably on the phone today. He does a great job with that. So when you're here, if I get started, I'm going to log right in. So we call this the dashboard of the Machining Advisor Pro. And as you can see, there's different functionalities that you see here, okay? But when I was talking earlier about the EDP numbers and the nomenclature and stuff like that, really when you initiate this program, it has a series of information that you need to fill in. I highly recommend that you spend the most time right here. This, as I mentioned, the material is always a variable, and the type and condition, the way the material has been processed is very, very important. Otherwise, you'll get wrong the incorrect speeds and feed information and with the cuts. So with this here, we'll get started. I'm going to type in a 4-flute end mill. You can see it comes up here with the nomenclature right next to the EDP number. Click on that. You have to click on it, and then it will come up and tell you everything about that tool. So you'll see here's the EDP number, the application, what it's used for. It has chip breakers. It's a variable pitch. It's in inches. It has a corner radius. Cutting diameter is 0.5, and etc. But the nice thing about here is this is also hyperlinked back to the website. Shows you if you're planning to run this job tomorrow, you want to know, hey, is there material available? So you can see it here. You can see the application operations that the tool was designed to do, all in the same spot. And then you can jump right back into Machining Advisor Pro. All that is a hyperlink. Each one of these boxes, you'll see tool, material, operation, etc. You'll see there's a question mark here, and you can keep drilling down further and further until you get the information that you're looking for. This one here, we'll do low alloy steel today. We'll talk about 4140, and you can see here, there's different conditions that the material is in. You get down into here and you start changing the quenching temperatures, the material gets harder and harder. So annealed we'll go with today just to keep it simple. And when we look at the type of milling, it's going to be general milling for everything. And then you'll see here, as far as the operation type, this is where we start planning. How are we going to process this part? Are we going to use high efficiency? Are we going to do finishing, full slotting, traditional, or tricordial slotting? In this arena here, if you're not sure what you want to do, click this icon here, and it will actually open up and give you the information about the toolpath you're about to select. Note here, these are not high efficiency toolpaths. These are probably the least desired, especially this one when you're zigzagging back and forth. So keep that in mind. Just read the little notes on the bottom. These two here, primarily everything you're going to be running with the high efficiency milling along with some tricordial milling. The other thing, when you're in the material, is maybe you're not sure what the hardness means and stuff like that. So you can hit this here and hit learn more. And once you get here, remember I told you can bury down a little bit further, and you'll find that it has this all laid out as far as what material group that you're looking for. What is the subgroup? You can see here how you can categorize your materials. Subgroup for ferrous and non-ferrous steels, cast irons, and stuff like that as well. The other thing, anytime that you're in here and you have a question, you can hit help here, and a lot of times this is the information that you're looking for as well. Pretty much the same what I just showed you. Here has some additions, how to create a desktop icon and stuff like that. It's right there in the program. So let's go back to select the high efficiency toolpath. Let's go to spindle connection. We'll leave it Cat 40. And then let's go to a shrink fit. You'll notice that it comes up with these flags, and basically this is for your safety. We have to do this just to make sure, you know, safety's key for us. It's just telling you, use this toolpath selection only if you're employing toolpath strategies with high performance CAM packages. So with the ESPRIT, that's what it's telling you. And then you'll see sometimes a banner will come up if a machine may not be capable of running the parameters that are selected using the Machining Advisor Pro. And if that's the case, you can make some adjustments here as far as your feeds and speeds. So we'll put in 10,000 RPMs. Let's go 12. That's going to be your max RPM, and this is going to change from machine to machine. And then your max inch per minute capabilities, let's say that's 1,000 inches a minute. So at that point, you can see the Machining Advisor Pro, you've given it enough information to say, hey, if you're going to start out, this is where we would start. So when you think about the stick out length of the tool, that's from the bottom face of the tool to the face of the tool holder that you're using. So it's in a ratio that's set up at 300% in this case. The radial depth is considered your AE, and then and that's just the percentage of the tool diameter. George showed you here that you can lock these things, and you can start, you can adjust different things using the slider, or you can come back and say, hey, I want to go back to what that was and just leave it there on both of them. So you can see here, if we were running a 4-flute end mill, you would be running a annealed 4140, 1,222 surface feet, 11% radial width of cut, and your RPM would be 9,335 RPMs. Feet per tooth would equate to 5,000 feet per tooth per revolution, and that would result into a 0.0031 chip thickness. Again, your metal removal, this right here should be the way you plan your operations. If you got good fixturing, everything's robust, tool holders stout, machine stout, there you go. You can, that's very doable, 16 cubic inches a minute of metal removal. Again, you can come down here and you can adjust these sliders anywhere you want to, okay? Rule of thumb, you'd never wanna run the highest speed with the highest feed together. If you're gonna run high speed, it's a balance between feed and speed, because what kills tools is heat and pressure. So when you exceed the limits of the carbide, you're gonna start having some issues. So just be mindful of that. Let's go back here. The main amount of time that you spent was really populating the right material, picking the right strategy and stuff like that. Let's say I want to come over here and now I want to change that tool to another tool. All I have to do is just double click in this area here and just hit Control A. And once I have it highlighted, or I can just slide it across and highlight it as well, I just start typing in a different number. And you can see it's this particular one, we're going to go into a 5-flute tool. Okay, again, we left this alone. We're doing a high efficiency, and you can see how it recalculated the feeds and speeds. That actually stayed the same. This went up to 233 inches a minute, 16.9. Let me go here. Yeah, make a change there. That'll do it. So with that output, what George was showing you, all you do is hit the PDF button here and then hit OK, and you'll get, it will actually download to your computer, or you can just open it to view it on the screen, so you can start populating the CAM package. So with that tool, I'm going to stick with the 5-flute. 5-flute's pretty universal in steels. And let's just take that same tool and let's go into finishing. All right. So you can see all I did was take that same tool and put finishing, and it adjusted the parameters. The radial depth of cut now went to 4% or 20 thousandths. Full length of cut, and it shows the angle of engagement, a tool engagement angle. here. Now this is in representation of the slide I showed you initially about the conventional or high efficiency milling. So let's go through here quick. We're getting to a time constraint here. Again, I took that same tool, half-inch tool. We went full width of cut. And as you can see here, its axial depth is 60% or 300 thousandths. And you can see how it adjusted the feeds and speeds on the side here. Another thing to consider is your work holding security. You can take these sliders and move them. If it's loose, it's not so rigid. I would definitely start there. And on your feeds and speeds, you know, anytime I run my first part, I'd like to say that I have full confidence everything's perfect, but a lot of times I will take the feed rate overrides and spindle speed, and I move them down and work just to make sure and kind of ease into it. So just know that you can do that. So that's full slotting. Let's go to traditional roughing, and you can see again it changed the axial depth of cut now to 90%, and we're going to do a step over of 30%, which is 150 thousandths. Adjusted the parameters here. Again, you can output it if you would like. Then you go into Tricordial Slotting. Okay, so very, very important when you do Tricordial Slotting to realize that usually the general rule of thumb is if you're going to Tricordial slot, the tool should be 25% smaller than the slot that you're going to produce. Otherwise, you start running into chip compaction and stuff like that. I've seen people, you know, you do it and get away with it, but it's very unpredictable when you do that. So hit OK, and you can see we can get past that. And then I want to talk to you about when you think about Tricordial slotting, if you're stepping over 6% or 30 thousandths, if you're doing a true radius form, like you see here, when you hit the center of that form, the engagement actually is more. So 30 thousandths is probably more like 45 when you hit the center. If that's your tool path, which it wouldn't be using ESPRIT's profit milling, yeah, they control it and they can change the radius size, so it's not as extreme. But if you're writing a macro or something like that to do Tricordial slotting, just be mindful that when you hit the center, that number is going to spike up. And if it's, you need to reduce the feed and speed to reflect that. So let's go from here and let's talk about Helical Plunge. This is a pretty cool function here. If you're limited on tool space or whatever, you may take this thing and drive it to the bottom of a pocket and start an interest hole and then start doing profit milling on the way out. The nice thing about this function here is you can see it actually gives you how long it's going to take, and then you can see a G-code as well. When you get to the G-code, if you double click in here, you can actually hit Control-C and you can copy that into a Word document or a text file or something like that, and then take it, put it on a thumb drive and put it in your computer. This here is it's set up incrementally as an incremental based thing, so you can take this and you can make shifts to it, and you'll see it will automatically make adjustments on the fly. Whatever your coordinate position is, you may have 4 or 5 different holes across the top of a part or something. Okay, it looks like we're coming down to the wire here. I'd like to leave some time for questions. Hopefully this was informative for you. And I'm gonna hand it back to George.
All right, thank you guys. This is Dan. So we're gonna get into the Q&A, and before we do, I just want to remind everybody, because we've had a lot of requests about virtual training amidst the pandemic, and that is part of our consulting services that we offer. So anything from basic to advanced training is all available online. We've also had a lot of requests for contract programming and knowledge base implementation. and those are services we offer as well. So with that, we'll go ahead and get into the Q&A. We had a few questions that happened throughout the presentation. The first one I will give to Darren. Someone was asking if they're going to release the Micro 100 line for for the ESPRIT tools, I would assume.
You know, I would be lying to say yes, but I'm sure that it's definitely in the workings. I'm not sure where it sits on the priority list, so I hope that answers your question.
Okay. And so we are running kind of low on time, so if we don't get to anybody, we will definitely follow up with you individually. But one question I would like to go over, someone was asking about the tilting, avoid collisions by tilting option. So I was going to see, George, if you could open up that operation, we could just go over some of the parameters in there. So as you can see, he has the avoid collisions by tilting option. There's a few other ones there as well. You could avoid by trimming, so it would alter the toolpath to avoid the collisions, or you could just check and report on the collisions, which would give you some feedback in your output window explaining how long of a tool you would need to be able to avoid the collision and some other information. And then beyond that, you have the ability to set a tolerance, an angle, and enable smoothing. So, you can set what the maximum angle is going to be. In this case, it was 20 degrees. And then there's also some smoothing options that are available, which are available in our other 5-axis cycles too. So now, of course, you would have to have a machine that's able to do this, which was also part of the question that was asked. So if you didn't have a machine that could tilt to avoid the collision, you would just need to make sure you have a tool long enough to get to the bottom of the pocket. But this is a really powerful tool that's built right into our 3D cycles. And personally, I use it a lot as well. So we thought it'd be a good idea. This is a perfect situation to be able to show it. So let's see. Another one for Darren. Someone was asking about metric options. So I think everything you were showing was an inch. Is there capability to do things in metric?
Yes, we have a product offering in metric. It's a limited product offering, but yes, we do. If anybody needs metric as something they don't see in the catalog, we can do that as a special as well. But yes, the Machining Advisor Pro does work with metric tools as well.
Okay. So actually, we'll do one more Helical or Harvey question. Let's see. Is there any possibility that these tools that you guys would be going into Machining Cloud for Helix or Harvey? Has there been any conversations about that?
There have been some conversations, but again, there's a lot going on, so I'm not sure where that stands in the list of things.
Okay. All right. So we have one more minute, and it looks like someone was getting an error trying to register to download the app. Is it available for a desktop version?
It is. Most of the time when you get that error, from my experience, the email that's being used has already been given a password. And if you forgot the password, if you just go through the exercise and say, I forgot my password, you can reset that. Most of the times, that's the issue. The other thing to keep in mind of, and I meant to mention this earlier, is you want Chrome. You want to use Chrome as your browser, and that if you have any issues, most of the time that cleans it up as well.
Oh, that's a good piece of information there. So, and then real quick, someone was asking about profit milling for a contouring operation. It's not currently available in a contouring operation. Typically that would be reserved for more finishing type operations. But if that's something you would like to see, I would encourage you to submit an enhancement request to us with the justification. And I'm going to follow up with Shane after the session, but you know, that's something we could certainly consider if there's a need for it. So with that, we are right at an hour, and I appreciate everybody's time and encourage you to join the next one. So thank you again. Have a good day.